Okay guys, welcome back. Today we're doing lesson 2.2, characteristics of quadratic functions. Now I want you to remember that we are in chapter 2, and chapter 2 is just about quadratic functions. So whenever you graph something for chapter 2, it needs to look like a parabola. Okay, we're not going to be doing absolute values, we're not going to be doing linear functions. We're going to be strictly doing quadratics. Okay, the first thing we're going to talk about is the axis of symmetry. And the axis of symmetry is a line that divides your parabola into mirror images and passes through the vertex. I think I got 2 R's in there. Through the vertex. Okay? And for our purposes right now, we're going to start off with vertex form. So we're going to use f of x equals a times x minus h squared plus k, where your vertex is at h comma k. Your axis of symmetry is at x equals h. Okay, so that we can just see from the vertex form. It's really easy to find it. Okay, so you're going to take the opposite of what you see in here. You see a minus h, your vertex will be positive h, and the k is going to be just like you see it. So whatever you see, that's exactly what you're going to put there. So let's take a look at an example. Example 1. And here we have f of x equals negative 2 times x plus 3 squared plus 4. And what I want you to do here is I want you to tell me what the axis of symmetry is, what the vertex is, and I want you to graph the function. Okay? So really easy. We can look, because this is in vertex form, your vertex is going to be the opposite of what you see here. So negative 3 comma and then 4. This one does not change. So that's your vertex. And your axis of symmetry, which I'm calling AS, is going to be the line x equals negative 3. Okay? So that's the first 2 things that we need. Axis of symmetry, x equals negative 3. Please do not write the axis of symmetry as just negative 3. The axis of symmetry is a line and has to be written like a line. So it's got to be either x equals or y equals. In our case, x equals. So definitely make sure you have the x equals. And the vertex, again, is at negative 3, 4. And at this point, we can go ahead and graph this. So we have the axis of symmetry at negative 3, 1, 2, 3, so right there. And remember, the vertex must always be on the axis of symmetry. So if the axis of symmetry is at x equals negative 3, your vertex must have negative 3 as its x-coordinate, and then the y-coordinate is 4. 1, 2, 3, 4. It must be on that line of symmetry, or axis of symmetry. This function is going to open down, and we see it because of the minus sign, which is great. We just need a few points to figure out kind of where those points are going to land. So again, you put your vertex in the middle somewhere, negative 3, 4. You're going to pick a number smaller than -3. So how about -4? And we can pick one bigger than -3, like -2. We can actually pick two that are bigger than -3. And let's just do -5. Why not? Now, because this is a symmetric function, whatever I get for -5 is going to go with whatever I get for -1. It's going to be the same thing. Whatever I get for -4 will be the same as -2. And what I mean whatever I get, it's whatever I get when I take this number, this value of x, and plug it into the original. So let's go ahead and do that. Let's do -5. So here we have -2. Wherever there's an x, I'm going to put a -5. Okay. Order of operations says we must do parentheses first. So -5 plus 3, that's -2. Exponents, so -2 squared, that's 4. And then order of operations says multiplication and division. So we're going to do that. -2 times 4, that's -8, plus 4, that's going to be -4. So at -5 we have -4, and at -1 we have -4. Again, if you don't believe me, you can just plug in a -1 and you'll see you get the same thing. So here we are at -3, -4, -5, -1, 2, 3, 4. And at -1 we are also at -4. Let's go ahead and plug in a -4 and see what we get. We have -2, and then we have -4 plus 3 squared plus 4. We do what's inside parentheses first. That's going to give me -1 squared. -1 squared is just 1. 1 times -2 is -2 plus 4, and that's going to give me 2. So I'm going to get a 2 here, and then I get a 2 here. So at -4, I'm at 2, and then I'm at 2 at -2. Connect your dots, and there's your function. Please make sure this is a curvy function. This is quadratic, okay? Not pointy, not like a absolute value. All right. Oh, one other thing. This vertex up here, when it's when a function like this is opening down, like this one, because it's a negative, the vertex up here is a maximum. So that's a new thing. And all it means is that y has the maximum value here. The vertex here is at -3, 4. 4 is the biggest value of y that you'll have anywhere in that function. So that is the maximum value. Okay? All right, moving on. Let's take a look at the next page. All right, so we did vertex form. Let's go ahead and do standard form. Standard form looks like this: ax squared plus bx plus c. This is the form we use, for example, when we're going to do, we're going to use a quadratic formula or something like that. This one requires you do a little bit of math to find the axis of symmetry. Unlike vertex form, which was easy to spot, standard form requires us to do a little bit of math. And x is going to equal, x being the name of the axis of symmetry, the line, x equals -b divided by 2a. All right? And then your vertex will have the x-coordinate being whatever that is, -b over 2a. And this will make more sense in a minute. And the y value of the vertex will be the function evaluated at -b over 2a. Again, don't worry too much about this. I'm going to show it to you and how to do an actual problem. So for now, just take my word for it. And then this C out here is our y-intercept. That is where the function is crossing the y-axis. Okay? So it's going to be at 0, comma, whatever C is. All right, let's take a look at a real world problem, or as real as it gets in math. Example number 2. Let's put some numbers here. So let's say here we have the function f of x equals 3x squared minus 6x plus 1. I want you to find axis of symmetry, I want you to find vertex, and I want you to graph it. Okay, so the same things that I asked in example 1, which had to do with vertex form, I'm now asking in standard form. So the first thing we have to do is determine what A is, what B is, and what C is. A is 3. It's the coefficient of the x squared term. B is negative 6. That's the coefficient of the x term. And C, which is my constant, is 1. So now I'm going to use my formula for axis of symmetry, which is x equals negative b over 2a, to find what that axis of symmetry is. That's what I'm looking for here. So negative b, that's going to be negative 6. Okay, so it's the opposite, negative b, the opposite of that negative 6 over 2 times a, which is 3. That's going to give me positive 6 over 6, and that is just 1. So my axis of symmetry is the line x equals 1. Make sure you write the whole thing. X equals 1. That means my vertex is at 1 comma something. And the way I find that something is to go back to the original function and plug in a 1. So let's go ahead and do that. Just find another marker. So that's going to be 3 times 1 squared minus 6 times 1 plus 1. Again, order of operations requires us to do parentheses and exponents first. So 1 squared is 1, and 1 times 3 is 3. 6 times 1, that's 6. But it's negative 6 times 1, so it's negative 6 plus 1. So negative 3 minus 6, is negative 3, plus 1 is negative 2, and that is the y-coordinate of your vertex. All right. Oh, and one more thing that we can do here, because we have a C here. The y-intercept is at the point 0, comma 1. The 1 is coming from here. The 0, because x has to be 0 if you're crossing the y-axis. So we got a lot of stuff here now that we can work with to graph this. Okay, so we have an axis of symmetry at x equals 1. We have the vertex at 1, negative 2. Remember, it must be on the axis of symmetry. We can see that this is going to be a positive function because there's no minus there. So this is going to open up like that, which is great. And we also have a y-intercept. Let me make this a little bit larger. Maybe not that large. A y-intercept at the point 0, 1. Now, because we have symmetry here, I can reflect this point over the line or the axis of symmetry, and that means there has to be another point right over there. All right, and then you just connect your dots and you're off. Oh, that looks awful. Sorry about that, guys, but you get the idea. Okay, It's a little hard sometimes to do this while I'm drawing and looking at the screen, but not looking at my hands, so it gets a little crazy. And that's that. That's basically it. Now this one, because it's opening up, this vertex down here is a minimum. If you remember the other one we just did, this one over here, it was a maximum. So when your function opens down, it's a maximum. When it opens up, the vertex is a minimum. This is the smallest value y is going to have. It's at 1, -2. So the smallest value of y is -2. Everything else is above it. Okay? Let's just quickly review what happens when the function opens up and when the function opens down. So this is going to be maximum and minimum values. So let's do a function that opens up, shall we? We'll do this one, and I'm just going to pick any old axis of symmetry. That's my husband moving furniture out there. Oh gosh. And let's say this thing is opening up like that. Okay? This is going to be our axis of symmetry. So x equals -b over 2a. This point here is the minimum. As far as the function increasing or decreasing, here the function is increasing. Here the function is decreasing. Okay, so this is your typical quadratic function that opens up. Let's add a little bit more to it. So this is more math symbols, but I just want you to make sure you understand. So this is in standard form, and obviously a is greater than 0, because if a is 0, then we're left with a linear function. Your minimum value is whatever f of -b over 2a is, right? You need to take this and plug it in to find out what the y value is. And your range, because this is opening up, is going to be y greater than or equal to, well, whatever that value is, right? Whatever the y value is. Let's say this is the point 2, 2. So we're looking at that value. That would be this. Minimum value would be at 2, and the range y has to be greater than or equal to 2. And we're looking at this 2, the y one. And then this is decreasing and increasing. This will be decreasing when x is less than -b over 2a. In this case, -b over 2a is just 2. And it's increasing when x is greater than -b over 2a. In other words, when it's bigger than 2, it's going up. All right, so that is your typical opening up scenario. Let's take a look at this opening down. Okay, so in this side, why not? Let's go ahead and do the axis of symmetry here also. But in this case, at 2, 2, we'll have the same vertex, but it'll be opening down. Okay? So here the axis of symmetry is the same thing, negative b over 2a. And this point, which is the vertex, instead of being a minimum, will be a maximum. And this just happens to be the same point, 2, 2. Over on this side of the function, going this way, the function is increasing. And over here, the function is decreasing. All right. And now we're just basically going to copy the same stuff here, but just a little different. So f of x, again, ax squared plus bx plus c, where a is greater than 0. I'm sorry, less than 0. I said over here a had to be greater than 0. Yes, it has to be a positive a in order for it to open up. I thought I said something about a being equal to 0. If a is 0, then you have a linear. So we don't have that situation. A has to be greater than 0 over here so that this opens up. It's positive. And here a is going to be less than 0. It's going to be a negative number, so it's going to open down. In this case, you're going to have a maximum value. Oh, and there's my dog, because it wouldn't be a video without him, right? The maximum value is going to be at negative b over 2a when it's plugged into the function. So whatever the value is of negative b over 2a plugged into the function, that's going to be the maximum value. Notice here it was the minimum value. And the range, there are some errors in the notes online, so I'm just letting you know this video is the most up to date. So you may want to check your notes with this. The range, because it's opening down, is going to be y less than or equal to instead of y greater than or equal to, and then f of negative b over 2a. And finally, your decreasing and increasing. It's decreasing when x is greater than negative b over 2a. Again, I think there's a mistake. Oh, no, I got it. It's correct. This part is correct on the notes. But just make sure you check, because sometimes I make mistakes. It's decreasing when x is greater than negative b over 2a, and it is increasing when x is less than negative b over 2a. It's over on this side, so it's increasing there. Okay? All right, give you just a second to digest that. Let's take a look at example 3. And here we are going to do a problem with actual numbers in it. So we have f of x equals 1/2 x squared minus 2x minus 1. So you need to figure out what a is, what b is, and what c is. We can tell right away if it's going to be a minimum or a maximum, if the vertex is going to be a minimum or a maximum. If this value, the a value, if it's positive, you're going to have a minimum. So this is positive, so we know for a fact this is going to be a minimum, because if it's positive, it's got to do that. Yeah? If it was negative, we would say right away that it's a maximum, because it would be opening like this, and this would be a maximum point. Okay? So a is 1/2, b is negative 2, and c is negative 1. And again, because a is greater than 0, this is a minimum. All right, let's find the axis of symmetry. That is x equals negative b over 2a, which is negative 2 over 2 times 1/2. That's going to give you positive 2 over 1, which is just 2. So your axis of symmetry is the line x equals 2. Please make sure you write it as a line. X equals 2. All right, so now we need to find our vertex. And in order to find the vertex, we know the x is going to be 2 because that is coming straight from the axis of symmetry. And now we need to take 2 and plug it in up here. So this is 1/2 2 squared minus 2 times 2 minus 1. Again, do your exponents first. 2 squared, that's 4. 4 times 1/2 is the same as 4 divided by 2. That's going to be 2. Negative 2 times 2, that's negative 4 minus 1. So 2 minus 4 is negative 2 minus 1 is negative 3. So we've got our vertex. We've got our axis of symmetry. And another thing we have, because this is in standard form, we know that our y-intercept is at the point 0, negative 1, right? Because that's where it's crossing the y-axis. So we've got enough information now to go ahead and graph this really quickly. We have axis of symmetry at x equals 2. We always kind of do this as a dotted line. Sometimes you'll see it as a solid. I like to do it as a dotted line. We have the vertex at 2, negative 1, 2, 3. We know this is opening up because my a value is positive. And I also know that there's a y-intercept at 0, negative 1. Because of the symmetry of this function, I can just reflect that point and see that there's got to be another one right there. And basically you're done. Okay, again, this is a minimum. And it's at the point 2, negative 3. That means that the smallest y value of this function is negative 3. Okay, so we've got one more type. We've done vertex form, that's what we started with. Then we did standard form. And now we're going to do one more type called intercept form. And you guessed it, it has to do with intercepts, but not the y-intercept. This one has to do with x-intercepts. So intercept form. Looks like this. F of x equals a times x minus p, x minus q, where obviously our a cannot be 0, because if it is 0, everything else goes to 0, and you're left with just a constant, right, of y equals 0, which would be your x-axis. Let me see if I can focus that a bit. And p and q are the x-intercepts. And the easy way, or the very easy way to find the axis of symmetry is the following. X equals p plus q divided by 2. And this makes perfect sense if you think about it. All right, so let's for a second just think about this. Let's say you have a function out here, and there's an intercept at 1 and at negative 1, and let's say that's the vertex. Let's just make that up. Let's say that's our graph, and we can see that there's an intercept at 1 and at negative 1, right? The points 1, 0 and negative 1, 0. These are x-intercepts. X-intercepts. If we wanted to find the axis of symmetry, you would have to look for the point that's in the middle between these two. Because if the function is divided by the axis of symmetry into two perfect halves that are mirror images of each other, that means that this line here, this axis of symmetry, must be midway between the 2 points. So basically what you're finding is the midpoint between the point 1, 0 and 1, and negative 1, 0, right? So this is, let's say, you could call it whichever one can be P, whichever one can be Q, doesn't matter. So P plus Q would be 1 plus negative 1 divided by 2. Well, that's 0 over 2, which is 0. That means my axis of symmetry here is 0, which in fact it is, sorry. It is that y-axis, which is also known as the line x equals 0. But I just want you to see why it's very easy. It's just the midpoint between the two x-intercepts. Okay, once again, the parabola opens up when a is greater than 0, and it opens down when a is less than 0. All right? Okay, let's take a look at an example with some numbers. This one comes from your book, and it's called Example 4. And we have f of x equals negative 2 times x plus 3 times x minus 1. And what I want you to do is you're going to find, obviously, the x-intercepts here. You're going to find your axis of symmetry, your vertex, and you're going to graph. Okay? So just by looking at this, we can see that the x-intercepts are going to be at the point negative 3 and 1. So at the point negative 3, 0, and at the point 1, 0, you're going to have x-intercepts. Normally we just say at negative 3 and at 1. And if you look at the notes, I did make a mistake. Let me show you the notes that are on there really quick. I mistakenly last year wrote y-intercepts. This should be x, so there are mistakes in those notes, and I just saw that one. It happens. It happens. So let's go ahead. Let me go ahead and just do an xy coordinate plane here. Let's find the axis of symmetry. The axis of symmetry is x equals, this one can be P and that one can be Q, it doesn't really matter. So it's negative 3 plus 1 over 2, and that's going to give me negative 2 over 2, and that's just negative 1. So the axis of symmetry is at x equals negative 1. So let's put our x-intercepts. We have one at negative 1, negative 2, negative 3, and we have one at 1, 0, one at negative 3, 0, and one at 1, 0. And the axis of symmetry is at negative 1. So it's x equals negative 1. All right, now we need to find our vertex. So if the axis of symmetry is at negative 1, the vertex will be at negative 1, something. We're going to need to plug in that negative 1 here. So negative 2 times negative 1 plus 3, negative 1 minus 1. So negative 1 plus 3, always do order of operations, guys. Take care of your parentheses first. 3 minus 1, that's 2. And then we have negative 2. And here we also have another negative 2. So negative 2 times 2, that's negative 4. Negative 4 times negative 2 is positive 8. So at negative 1, we're going to be at 1, 2, 3, 4, 5, 6, 7, 8. Now this guy is opening down because of that minus sign, so this is going to be a maximum. All right, and we've already got these 2 points here, so this makes it really nice and easy to graph. All right. And that, guys, is the end of 2.2. I'll see you soon for 2.3. And actually, I'll be doing a video also to cover the study guide for the quiz on 2.1 and 2.2. See you in a bit.